Hi everyone, I'm Rishabh and welcome back to Rishabh's World. Today, I am going to show you and talk about the topic of my school science exhibition. The theme of our science fest was Energy and Panchamahabhutas. So I decided to do a project that was centered around all of these. I hope you like it. Please hit the like and subscribe button and click the notification bell icon so that you won't miss any of my videos. So let me first show you my entire project. I'm going to switch my camera. Here, can you see me? So I hope you're able to see this. I will zoom in to show the details as we proceed. So my topic is related to energy and electromagnetism and its relation to Panchamahabhutas. Did you know that Hans Christian Ørsted found out that when an electric current passes through a wire, it creates a magnetic field? This helped future scientists to use this information to work on electromagnetism. My model is a working model that uses the electromagnetic field to convert electrical energy into mechanical energy. This machine is called an electric motor, which makes our work much easier. Here we have an example of a simple DC electric motor. I will also be showing an example of a simple DC generator turbine. Motors are used in many modern appliances so that we don't need to use human effort to do most of the work. Electric motors are used in cars, kids' toys, fans, and many electrical appliances in our daily life. So this is my model. So these two things here are my L clamps. These will work as a stand and as a commutator for this. This is my induction coil. This is the part that's going to be spinning. As you can see, it has many loops. This is done so that when the electricity passes through this coil, because of the many loops, it will create a strong magnetic field according to Ørsted's law. Next, I have a neodymium magnet here. A single neodymium magnet is very small and it's not that powerful. So I decided to stack up many neodymium magnets together so that it can have enough power and will be big enough to reach the coil. Next, I have a switch and then I have a power source. I'm going to switch this on so that you can see it working. You see the sparks? See? So I'm just going to switch it off now. So how this motor works is that when the electricity comes from the positive terminal of my battery into this clamp, it will pass through my induction coil. When this happens, because of the many loops, it will create a strong magnetic field. Because of this magnetic field opposing the neodymium magnet's field, it will cause this to spin. And this cycle will continue on until I remove the power source or if I switch it off. The workings of motors are based on John Ambrose Fleming's left-hand rule. Fleming's left-hand rule can be stated as stretching the forefinger, middle finger, and the thumb of the left hand such that they are mutually perpendicular to each other. Here, the forefinger indicates the direction of the magnetic field. The middle finger indicates the direction of the current in the conductor, and the thumb indicates the direction of motion. Motors work on the principles of electromagnetic induction. Electromagnetic induction is the basis for all motors and generators. Now, speaking of generators, I also have a working model of a simple electric generator. Here, I've used an old computer fan as an example of a generator turbine. Let me show you how it works. What I have done is I have connected a red LED here to show the generation of electricity. And I have put a thread for a pulley crank system because it was really hard for me to actually blow into it so that I could spin fast enough to make enough electricity so that this LED could glow. So I'm just going to show you how it works. So I'm going to pull this, and when I pull this, the motion will make electricity. I'm going to do this a couple of times so you can see. And remember, pay attention to the bulb so that you can see it glow. Can you see it glow? Right there. So a generator is nothing but the opposite of an electric motor, where mechanical energy is converted into electrical energy. It works on the principle of Michael Faraday's laws, where when a coil or a wire passes through a magnetic field, it will generate an electric current in the coil. The workings of generators are also based on John Ambrose Fleming's right-hand rule. Again, in this rule, the magnetic field is represented by the index finger. The thumb shows the motion of the coil, and the middle finger shows the direction of the current that is being generated. Now let us see how our model is connected to all the Panchamahabhutas. Here in the model, I've shown the 5 sources of energy generation based on the 5 elements or Mahabhutas. You will notice that we will be using the same turbine and generator system to produce electricity from all these sources. First, representing Akasham, or space. This is different from solar cells, mind you, that convert light into energy. But here, solar thermal power systems use concentrated solar energy to produce steam from water using curved mirrors and focusing the sun's heat. The steam is then used to run the turbine, which powers a generator to produce electricity. Next, we have wind power generators, representing the Vayu element. Wind turbines use the force of wind to make electricity. Wind turns the propeller like blades of a turbine around a rotor, which spins a generator, which creates electricity. The next element is fire. Here we are talking about coal thermal plants. We have been using this form of energy for a very long time, and most developing countries are still using it. Coal-fired plants produce electricity by burning coal in a boiler to produce steam. This steam, produced under tremendous pressure, flows into a turbine which spins a generator to create electricity. Mind you, this is not the cleanest method to create electricity, so we're transitioning from coal-powered plants to other renewable sources. The fourth one is hydropower generation plants, which represents the Jalam element. Here, the water flows through a pipe under high pressure, usually from a reservoir or dam, and then the water spins the blades in a turbine, which in turn spins a generator that ultimately produces electricity. And finally, we have the geothermal power generation plants, representing the Prithvi element. Geothermal power plants draw fluids heated by the Earth's core from underground reservoirs to the surface to produce steam. This steam then drives turbines that generate electricity. We also have many other forms of energy generation other than these mentioned. For example, nuclear power plants, which we are not going to be discussing today. As we all know that our civilization is growing rapidly and it is in need of great energy for its growth and development. We need to tap into as many sources as possible. Many of these sources of energy are already in existence, and some need to be researched and developed further. I hope you enjoyed the video. Thank you for watching, and bye!